Hello, everyone, and welcome to this week's Cribl Weekly Demo, Trimming Unneeded Fields from Events. So before we jump in, I just wanted to take the time to introduce myself to those of you that I haven't met. I am Desi Gavis-Hewson, and I'm the Sales Development and Sales Enablement Lead here at Cribl. Previously, I led the National Sales Development team at Industrious, which is a co-working company. And then before that, I was on the sales team at Media Radar, which is an ad sales enablement tool for ad sales people. I also helped build the sales development team at Trello, so really helping them figure out their freemium motion and how to convert folks from free to paid opportunities. So my path to Cribl is a little non-traditional for sure. I've been in a few different industries in my career. I think ultimately, though, it was just a no-brainer for me to come to Cribl because I love and I'm good at matching people with tools that give them more flexibility and choice in their business. And that's what Logstream provides. So lovely to meet you guys. Here's what you can expect on today's call. So almost every week, we'll be doing a demo of Cribl Logstream and walking through some specific use cases in the product. First, what's going to happen is I'll do a quick intro just to observability pipelines in general and Logstream for those of you who may not be as familiar with us or what we do. From there, we'll move into a full demo of Logstream. So we'll talk through the specific use case for that week. Obviously, this week, that's going to be trimming unneeded fields from your events. And then you guys will have the opportunity to ask some questions regarding the product. So the global data is growing at a 25% compounded annual growth rate. I think everyone in the world understands that to a degree. So if you take being in a global pandemic, for example, rather than our business meetings happening in person, they're happening on Zoom. And Zoom's generating data. So even if you think about it from a non-technical perspective, it's really easy to see that data is growing astronomically. And by 2025, enterprises are going to be managing 250% more data than they were in 2020. So the amount's growing, but there's another problem. Logging systems are already at capacity. I talk to enterprises daily with costs in the millions when it comes to licensing. And the infrastructure required to store this growing set of data can cost as much or sometimes more than commercial licensing costs. More data means you need more CPU dedicated to analyzing it, right? And for a lot of customers, the added infrastructure costs can be in the tens of millions of dollars. On top of all that, you get inadequate data retention in some organizations. So when your logging system is reaching its limits, a lot of people believe they have no choice when it comes to dropping data that they would prefer to keep around. So to get the answers that you need out of your environment, right, you have to onboard new sources of data. A lot of companies will drop large portions of high volume sources just because it's too cumbersome and costly to really analyze everything. You may also have retention policies in place to meet certain standards and regulations, but you might be having to guess how long you can afford to keep a wider set of data. You may need to revisit that data later if you're investigating a security breach or trying to understand long-term trends in your IT environment. And then for some use cases, keeping data on hand to analyze for years might be required, might be needed. Lastly, systems are optimized to handle data analysis and retention separately. So what that means is you often end up using a lot of different tools to retain and analyze all of your machine data. And adding each one of these tools also adds complexity and hidden costs. So like I just mentioned, environments are getting super complex. You have your object storage, your time series databases, your data lake houses. Each of these have their own agents and their own ingestion pipelines. So it gets tough to manage it all. And it really forces enterprises to make some hard decisions and hard choices about which data to send to where. And choices usually mean trade-offs. So you end up playing like this three-way tug of war with cost, flexibility, and visibility. So the more data you analyze and the longer you retain it, then the more it costs you. Obviously, standardizing on a single tool limits flexibility. And if you're dropping data to keep costs down, that could limit what you can learn from your environment or investigate over time. So how do you do it? How do you manage the trade-offs of analyzing everything you need to get insights from your machine data, formatted for all the tools you use without breaking the bank? An observability pipeline solves all of these problems. And what our product Cribl Logstream does is it helps teams implement an observability pipeline without replacing any existing tooling. So with Logstream, you can get complete control of your data. You'll have all your machine data in any format to any data store. Really get platform independence. We're vendor agnostic. So whatever you have currently in your environment, Logstream can work with it and work with your data. We're purpose built for machine data. So we're built with machine data in mind, which is always a plus. And using Logstream, you can still maintain full fidelity copies of your data. For example, replay raw data at rest and cheap storage to literally any destination you want. And all of that adds up to cost reduction. You're going to see decreased logging and monitoring costs. On average, we see about 30%. So one question that might be popping up for you is, Desi, doesn't data streaming already exist? Yes. And the data streaming solutions that do exist are not purpose-built for polystructured data. On the other hand, an observability pipeline is really purpose-built to work with even the most complicated data formats. The data you need probably exists in multiple sources with different protocols, right, that dictate how data is generated and collected. So you've likely got data coming in a variety of shapes, right? And those shapes may not always match the formats required by the tools you use. And then you probably also come across streaming solutions that just couldn't scale with your business requirements. Cribl Logstream can. We've tested it at over 20 petabytes of data a day. So we know it works no matter the size. So if you forget everything that I've said here today, remember this, please. Cribl helps implement an observability pipeline to route security and machine data to where it has the most value. We're going to help you slash costs, improve performance, and get the right data where it's needed in the formats required. With Logstream, you can reshape, reduce, or route data so that you remain compliant and get the insights you need in the most cost-effective way possible. So next, I would love for you to see the product. I'd like to introduce my colleague, David Maislin from our solutions engineering team. David, you there?
I am here.
Hello. Can you tell the squad a little bit about yourself? Who are you?
Yeah, so I'm a principal solutions engineer for Cribl out of the Midwest, St. Charles, Missouri. And I joined Cribl in October after a 10-year stint at Splunk, so I know my big data. And I'm really looking forward to presenting and giving a nice demo today of the full product, as well as showing how we can trim some Windows events and other events for that matter.
Love it,
so
love
let's
it.
begin.
Awesome. I'm going to
Shall
stop.
I begin?
Yeah, go ahead.
All right. So let me first share my screen. I believe you can see it, correct?
Yeah, I've got it.
Okay, so what you're looking at here, this is the master node. It basically controls worker groups, which are nothing more than a collection of workers. And workers are where you send your events, your traces, your metrics through for processing by Logstream. And you'd put them closest to the source, meaning if you have AWS data coming into an on-premise instance, you would have worker groups in AWS and maybe some worker groups for on-premise. And basically we work like this. Data comes in from various sources, like you see over here on the left. Kafka, SNMP, Splunk, Event Collector, syslog as well, because we can easily collect syslog data. And then on its way out, after it gets processed by routes and pipelines, lands in any number of destinations, one or more. And you can see things like this. If one of your destinations is having challenges, maybe it's maintenance update, or maybe it's hardware down, we do persistent queuing, so we can keep the data for as long as you have storage for, which you can plan for capacity, for as long as you need. And then when things catch back up, after you turn things back on, you're good. Now let's jump into the magic of Cribl Logstream. So I'm in the worker groups, and for this demo today, we have different groups, in this case, metrics, and logs, and we're going to jump into the logs worker group. What we see here on the left are the routes and the pipelines that are going to be processing based on whatever matches in the route, and then some sample data that we'll talk about in a moment on the right. So one of the first things I want to show you is that let's assume that we start with Palo Alto data. And in this case, we're saying similar to Splunk source type is pan traffic. That's our filter for the data. All data that matches this filter, and it could be a JavaScript expression, would then be processed by this pipeline, which says firewall GeoIP enrichment. Beyond that and below that, and data is processed from the top down, if it's not marked as final, but this one is marked as final, it's done. It's not going to process any events below this route because we finalized this specific data set. But you can see below that, all data, because it's set to true, is going out to S3. But since we finalized Palo Alto traffic, it would never make it to S3. So we have the ability to just move these around. And in this case, I'm just now saying all data will be processed into S3. It is not finalized, so the data itself will be copied down through these routes for processing. And let's talk about how we process some of this data. We'll start with trim big JSON data. That's looking at some source type of Lambda, and it has a description, and we're going to enter into the pipeline right here. This is a very simple pipeline because it has just a single function. One of the things that you'll note is we can document everything that we create inside Cribl log streams, routes, and pipelines, and group them all together and order them however you like. This function is going to remove multi-value header and null fields from raw using Parser with the Reserialize capability. So before we do that, I'm going to capture some data directly from the worker nodes. And all I have to do that is I can capture it right from there, or just to show you something, I can capture it also right from here, these little 3 dots. This is where you can change the order, group things like that. So we're going to select capture. And now we see that the events were captured. And this allows me to save them as a sample file. It's going to expire in 24 hours unless I rename it, so that I can build my pipeline around this data. I've saved that sample. The sample will now be captured in my data sets up here. I can take a look at these captures, like this is the trim big JSON data. And what we're going to do is explain this parser function and how it affects the event that we captured a moment ago. All right, so first off, this is JSON. We understand structured data. When you look at this event, it has multi-value headers as well as headers, 20 items apiece, and it's the same thing. It's redundant, except CloudFront host, except CloudFront host. So that's why we're going to remove the multi-value headers field and nested fields within that. And as well as we're going to remove the null values, because you really can't chart or do anything with null values. It adds no value. So looking at this reserialize function, we're going to process the raw events. We've said remove multi-value headers and everything underneath it. But anything that is not null, we're going to keep. Let's also add another field. Let's add, for the sake of this demo, request context. So just by typing in the name to the fields to remove and selecting save, we moved from the in, where the data started, and now we're in the out. If I expand this, what you'll notice is the multi-value headers fields have been removed, the null values have been removed, the request context field that I just added was removed, and so on. And let's take a look at our basic statistics for this event. Right here is in the single event, This is the aggregate of all the events that I have in my capture. I have reduced the size of this event with just a couple words in my fields to remove and an expression below by 65%. That's going to save a tremendous amount of license as well as a tremendous amount of storage. Anyone that might be consuming against their license 1 or 2 terabytes a day is now just indexing about 350 gigabytes a day, and they're only having to store that much as well. A tremendous savings to the license, to the infrastructure, and as well as to the long-term retention. Let's explore a little more complex set of functions within a route pipeline pair. Let's take a look at this Palo Alto firewall traffic route and enter the pipeline. And here you can see the groups that I talked about a moment ago. We've grouped these together to organize our pipeline. In this, we have some Palo Alto firewall traffic that I've captured earlier. And this is what it looks like as it comes in. We natively support receiving data over syslog, UDP, TCP on any port in the native protocol. And we allow you to do TCP with TLS as well out of the box. So if this is what the data looks like going in, this is what it's going to look like on its way out. And it's already different because we've removed all the initial syslog protocol header stuff off the front of the event so it doesn't confuse the viewers. We've reduced the events as well by 11%, but we've also extracted all these fields. In a sense, this is similar to what a data mod would be, an indexed extraction, but we did it to save the indexer's time, to increase the performance on the indexing tier. So you can literally do all the extracted fields up front and prepare the data so that when you receive it into a product like Splunk that uses something like enterprise security, in a sense, you're building the data model. You could probably turn off the data model and the accelerated data model, and you can also increase all the performance on the indexing tier as well. This first set of functions are going to through the extraction and the reduction phase. Step 2 says if you aren't Palo Alto traffic, you're done, you're finalized. That's that F right there. Don't enter this specific pipeline. But beyond that, sometimes people don't love regular expression. We have a parser function. The parser function is going to extract from this delimited event, which is comma delimited, all these fields. These fields I just copy pasted directly from the Palo Alto documentation, and it captures the fields to my liking. I can choose to not capture other fields or take fields out of my capture. Like if I don't want future use fields, then I just add them here to my list of fields. Maybe I want to use a wildcard. You can also note that the facility and the message have been removed because that's how we rewrote the event right here. The next thing is the drop function. If any of my events, maybe it's a debug log or a log subtype of start, match this specific filter, it's going to drop those events for further reduction. And finally, we have sampling. There are times in an organization when you're feeding data in that nobody will ever look at. And remember, we're already feeding the data to Amazon S3. So if you ever need all data, you can pull it back in minutes with Cribl Logstream, and we'll show that as well. What it's saying here is whenever I have some events that have no bytes in of 0, then I'll only pull in 1 out of every 5 events. And in case of trusted zones, like internal traffic from one zone to another, I could dramatically reduce and maybe pull in whatever decision you make, a 1 out of every 1,000 events. That's an order of magnitude difference in the amount of savings. This function is off. You just flip a switch, turn it on like this. If you wanted to deploy it, you hit save. And here's another nice feature that I love about Cribl Logstream. We're integrated with Git for version control. So even though I've just hit save, it's not deployed to the workers until I commit my changes. And I can make a note about sampling or whatever I choose to note there, hit commit, and then deploy the changes. Once I do the deployment, what happens is the workers are going to check in about every 10 seconds or so. And when they see that there's a difference in the change, They're going to pull down the change, and they're going to update their change, and they're going to process the events based on these new changes. What's great about that is there wasn't this very long downtime maintenance window rolling restart required. It was simple. There were no config files to mess up with. Everything is out of the box. Let's move into the next set of functions. And this is very important. For any given customer that's using like Splunk Enterprise Security or any SIM for that matter, we work with everything. Some of them allow you to do a mapping, a geo-IP mapping, using MaxMind as an example, where they take the source IP or the destination IP, and at search time, they display it on a map. But IP blocks change. And so if you didn't add the geo-IP information, like we have right here, we've added all of that using this geo-IP command, at index time, if there was ever a security investigation, maybe 6 months or a year down the line, you can't guarantee that the external IP back in January of last year maps to the same location, because that's why the MaxMind database updates daily, as an example. So we work with MaxMind databases and other lookup tables to support these types of capabilities. Other things that we can do, in this case, we don't just pull in the English because we are agnostic and universal to all the languages, but in this demo, I'm only keeping the English responses from the MaxMind database and removing all the other fields that I'm not going to need. Moving down the line, we also support DNS lookup and reverse DNS lookup, as well as allowing you to do one lookup to a specific DNS server in the 2.4 release, this is new, and another lookup to another server, maybe for internal addresses. We do reverse DNS, as well as lookups to flat files, including CIDR notation, and something very unique to us is a regular expression-based lookup, not just matching on a word with a wildcard against a specific knowledge set that you can add to our solution. You just import and you can edit directly within our solution, or you could script the update of threat list or something else like that. Beyond that, we go down to the final evals. Here, we're using a JavaScript expression to do a lookup against a set of compromised IPs. And if it returns true, then I can make a decision to flag that, add some additional fields to it, as you see right here, or drop it or make it go away. And finally, the last piece of this puzzle is to just make raw, as you saw earlier, the message field and remove any fields I don't need any longer. So that's a quick overview of some pipes, routes, functions, and showing how we can do enrichment and reduction of data. But remember earlier, when I talked about the fact that we are writing data to S3, one of the things that's great is if you ever had the need to pull back in data, you're not having to write a Python script and figure out buckets from within Splunk to try to figure out what do I need to recover, and maybe I'll just recover the entire block of all data that was indexed across a whole week because I don't know if it's there or not. Inside Cribl Logstream, we have collectors. So once you decide to write things out to a destination, you can then just choose the same destination you wrote to and say, you know what I need to do? Before I recover it anywhere, I'm going to preview my data set. I'm going to recover data maybe from a week ago for a full day. And this filter, when you write out the data, you can choose the partition expression, meaning you could add host and source type and user and department, anything you want to the path that's written to within S3. And then you could do the same thing within the filter expression. I could say source type equals Palo Alto, and then I know I'm only pulling back in Palo Alto events. And again, this is the preview. And when I'm all done, I can do a full discovery and then a full run to do the recovery. Once you select run, this is real. This is not demo. This is hitting S3. It's showing me the events. Just like earlier, I can choose to save it and build an entirely new route pipeline pair, routing the data maybe to a different destination instead of to Splunk. Maybe I choose to route it to a SIM. Maybe I've decided that I wanted to switch to a new MSSP and I want to just have all of my data indexed to them. I could route all of my untouched in an agnostic universal format data because it's landed in S3, it's not proprietary, directly to my destination of choice. So that's a quick demo of Cribl Logstream. I hope you've enjoyed that demo. But now I think before I move to the next step, should I pause here, Desi, and ask if there's any questions?
Yeah, that would be great. Let's do that. If anyone has questions just about Logstream in general before we move on, go ahead and use the Q&A feature in Zoom down below.
Okay, I see there's nothing in there. So what I'm going to do is I'm just going to continue on and show you some of the new capabilities of the release 2.4 that came out yesterday. So I start here, and what I want to do is show you, let's see, which one is it? Wrong one, a wrong one. I moved it right here. Okay, here we go. So within my routes, I have a route for Windows events. In this case, I have a pipeline. And in this pipeline, it's going to take XML event data, which looks like this. It's very large. It's often difficult to parse or even understand why they've done things. Like, why did they decide to put new lines and tabs in XML when they use commas elsewhere? That's interesting to me. I don't really like when they do that. So I'm going to step through the new capability of Cribl Logstream 2.4. So here we are. You saw earlier, this is what data looked like as it came in. We're now going to move to how it's going to go out. We start with the XML events. These events are pretty large, and I've seen some customers have over 1 terabyte or more of Windows event data that consumes their license. The very first thing I wanted to do, because it bothered me a lot, was remove some of these tabs and returns and replace them with commas. And that's what this replace new lines and carriage returns with commas does globally across the multi-line event, as well as if I find any curly braces or tabs within the event, then replace that with absolutely nothing, because that's where we see these tabs right here. Let's turn that on, and you'll watch this change happen before your very eyes. Now, there it is. You can already see the comma delimited privileges field, the multi-valued field, has changed. The event size has been reduced already without any parsing of the XML per se by 7% just as a start. Let's move to the new function. We have some native text processing functions that are native parsers of XML that we've added to Cribl Logstream. We do native parse XML, and then of course there is parse win events. What we did is we added some extra capabilities because Windows events were a little different. Some of the events have dashes in them, like we see right here. Other ones have maybe some strings of zeros, and maybe you choose to wipe out numeric zeros by just simply adding it to the list like that, and you hit save. And once I turn on this eval, another thing's also going to happen. I've played with this data a lot. There was one field when it parses, it had some extra white space in it. It could have just been a couple spaces, but hey, anything I can do to save my organization money, it matters. So if I have 10 billion events and I can save 20 billion bytes, that could be a couple gig a day, maybe 20 gig a day actually. So here, you can see things have changed pretty dramatically here. Look at raw. It's now automatically converted to a JSON object. Also, all those null values, those dashes, the zeros, the 0 by zeros, those are gone from the event. And again, I didn't have to do all these extra functions, but it was that I wanted to help my organization reduce their license. The event has already been reduced by 51%, but we've retained full fidelity. All the value is there. If you needed the original events, remember, they've also landed within S3. The next thing I want to do is show you a powerful function that's called Flatten. It's pretty straightforward. It's going to take these nested fields and values, flatten everything here out to top-level events to the depth of my choosing. I could have put 99 here if I wanted to, so that I can work with them a little bit more. So raw, don't worry about the fact that we crossed it out. We're going to get back to that and put it back together in a moment through the powerful functions of Cribl. We have raw event. It shows the nesting right here as the name. That's a long name, and you pay for the long names. I don't want that. So what do I want to do? I want to rename those top level fields, removing this prefix up front and one word, but keeping anything else. So let's turn that on. And now what you'll see is the events are very readable. This is much more with what I wanted as an end solution. I want those types of things to show up in my raw right here. How do we do it? We use the serialize function. And the serialize function is great because you get to pick. And here I said, don't use these fields. That's that exclamation point. But everything else is fine to serialize, put back into the raw event. In what format? In key value pair. Maybe I want it as JSON. It's that simple. You simply select the option. So let's hit on and save and take a look at our new event. Now the event is very easy to read. In fact, it's been reduced by almost 64%. Now your terabyte license that you were using for Windows events, you're now only using about 370 gigabytes. The final piece, I talked about this earlier. These are the indexed extractions, the meta fields, the data that lands in Splunk behind the scenes that you can use with T-stats for lightning fast searches and data models. If you want to keep it, that's good. But remember, there's your storage of the full event. That's the reality that you get to see. If you want to take them, make them go away, you just simply keep only the fields you care about and drop everything else. Once you hit save on that, now you see what you're used to seeing. Index, source type, host. We keep this in there so you know how it was processed. You can choose to remove that as well. And now, again, the full event length has also been reduced by over 50% for large scale infrastructure cost reduction. That's huge, especially if you're paying for like infrastructure pricing or virtual cores. You could reduce your total infrastructure and save a tremendous amount of money. So that is an overview of the new XML parsing capabilities of Logstream. And that's my demo for the day.
Awesome. Thank you, David. I didn't see any other questions come through while you were talking. So if you guys do have questions, please put those in below now. Otherwise, we can wrap up here early.
Any questions, anyone? All right. Well, thanks, everybody.
Have a great rest of your week, and we will see you. We'll see you next time.